Limits basically means the neighborhood of a point. We are not talking about that point, but we are talking about the very close to that point. Limit means neighborhood of a point. Like we are not talking about that point particular, but we are talking about the point that is very close to it. Okay, so definition of the limit if we write. So definition is limit x tends to a, fx will give you something as L. And what the definition says, as x approaches a, it's not equal to, x approaches a, x approaches a, so fx approaches L. Approaches L. Now, if we are approaching a point, let's say this is a point A, and if I have to approach this point, I have two directions. One, I can approach it from the left hand, means I'm going like this way. I'm approaching the point A from left hand. So that is called left hand limit. And if I'm approaching the same point from the right hand, like this way I'm approaching it. I'm approaching this point like this. From the right hand, if I'm approaching, so that is called right hand limit. Okay, so now we can write it like left hand limit. Left hand limit. And then we have a right hand limit. Right hand limit. This session will go starting from school to JEE level. See. Okay. So left hand limit whenever we are talking about, so that is written as limit x tends to a minus. A minus shows that we are approaching the point A from the left hand side. A minus fx, and let the value is L. L will be a some finite value. And what does it mean? Approaching the x from left hand side, or we can write it approaching x from left hand side. Left hand side. And we can say it is very close to A from left, very close to A from left. Now, next one, it can be limit x tends to A plus fx, and let us say it is giving me L. Again, it should be a finite number, finite. So that basically means the same thing, approaching x from the right hand side. We should know it. Approaching, and limit is the study of a point, a neighborhood point. Okay. Approaching from right hand side, approaching x from right hand side. Okay. And RHL will be very close to this from right hand side and left hand side. See, what does the limit basically mean? Let's say, like practical example I'm giving you. In a class of students, let's say there are 50 students in a class, and a new teacher came into class. Okay. And before entering into the class, someone told him like that one of the student in a class is like very smart, intelligent, he's studious, and like this. He heard about it. But now when he entered the class, he wanted to meet that student who is smart, who is the topper of the class, or smart person. But when he entered the class, he saw that he found that like that student is absent. Absent. So now he's not able to decide, like he wanted to meet that person, but that person is not present today. That student is not in class. So if he has to guess, like how is what he had heard literally about that student, is it correct or not? So how he can decide?
He can ask other students in class.
Other students, like, see, he will ask like where that person was sitting in class, and then he will see around position. That person, later topper is there, so he always used to sit in the front bench. What is the mentality like? So that person is absent in the class. That person that whom he came to meet is absent, so he will try to see the person surrounding, like his next bench here, next bench here, next bench here, like next bench. That person is absent, but he will try to analyze the situation who are sitting around this person, and from this he can make a particular guess. Got it? That person is not there, but he can make a guess about that student. Huh? That student must be like his friends. Okay? Understand? Limit is the same thing. We are just approaching it. We are just trying to study the neighborhood of the point. We are not studying that particular point. We are just analyzing the situation of analyzing the situation of the point from the left hand and from the right hand. And we are just trying to come to conclusion. Then we are trying to find the nature of the point. Got it? Understand? That is the limit. Limit is the study of neighborhood of a point, and that neighborhood basically means how we are deciding it by approaching that point from the left hand and from the right hand. We are very close.
But we won't ever come to the point.
We are not coming to that point. We are studying the nature of the point, very close to, very close to it. But not at that point. We are very close to it, but not at that point. Okay? Got it?
Okay.
Yeah.
Yeah.
So this is the concept. Limit, if someone asks what is limit, why we are studying limit? So by the study of limit, we are trying to analyze the nature of the point by studying its neighborhood. So limit is called a study of the neighborhood of a point. Got it? Understand? Yeah. Okay. Now, so if I am writing, like see here on the screen,
like even if we approach from left hand side or right hand side, it won't make much of a difference.
Much of the difference, yeah, because it is very close, very close. That's right. See, if we are writing x tends to a minus, that doesn't mean negative. That doesn't mean negative sign. That means we are
coming from left side.
Left hand side. Yes. Let's say if I'm talking about a point 2 here. So it doesn't mean that we're talking about a negative number. If I write 2 minus, no, it doesn't mean 2 minus is a negative number. 2 minus means just before 2, like 1.99999, like this way. Very close, 1.99999. Not a negative number. Okay, so that's what I said. A minus, a negative doesn't mean the negative number, but it only shows the left hand. Got it? Understand till here? Okay, good. Now see, next we have, let's say, now a condition is there. Limit x tends to a minus fx equals to limit x tends to a plus, and that is fx, and both are equals to L, and that is finite, Therefore, a conclusion can be drawn like limit x tends to a, fx exists. Function exists. If both the points we are getting equal, so we will say that the function exists.
So we have to analyze from both left hand side and right hand side.
Yeah, both. Left hand side and right hand. Okay.
Okay.
Got it? Yeah. Exist. Fine. Now see. Algebra of limits. Algebra of limits. No. algebra of limits. First of all, let limit x tends to a, fx equals to L, and limit x tends to a, gx equals to m. Okay, let's say these two things. Now, algebra of limits means reading the property addition, subtraction, multiplication, and division of limits. How we'll do that? The first property is limit x tends to a, f plus gx equals to limit x tends to a, fx, or minus also if it is. So we can separate the limits. That is the positive and negative sign basically means we can separate the limits. And this is fx, and this is limit x tends to a, and this is gx. Fine. Then
Yeah.
the second condition is limit x tends to a, fg x. So that will be limit x tends to a, fx multiplied by limit x tends to a, gx. We can, limit can be separated for the multiplication also. The third situation is, now limit x tends to a, if they are divided, f upon g, and this is it. So that will be, they can be separated, L over m. Let's say f, and you can write it like this way also. Limit, they can be separated. Limit x tends to a, fx divided by limit x tends to a, gx. L over m is the value, and the m should not be 0. The denominator can never be 0.
Okay.
Noted. That's three condition. Now one more condition is there. Now, next condition is like, okay, limit x tends to a, kfx. K is a constant. K is a constant. So that will be k limit x tends to a, fx. That will be kn. Okay, got it?
Yeah.
Now the thing is that why we are reading the limits, why we are trying to understand the why we're trying to read about the neighborhood of the limit, because limit is basically used to solve the indeterminate forms. And what is this indeterminate forms? I will tell you. The limits are used for solving indeterminate forms, and we should know. Indeterminate forms. Indeterminate forms are like 0 over 0, infinity over infinity, infinity minus infinity, 0 times infinity, then infinity raised to the power 0, then 0 raised to the power 0, and 1 raised to the power. These are called indeterminate forms because these are not defined. Like these exact values can't be found. 0 upon 0 if something comes, so exact value cannot be found as well. So limit is like approaching but not achieving. It's approaching but not achieving. Okay, now next we have methods of solving the limits. So you must be knowing few methods, like what you have learned, methods of solving the limits.
Yeah, I think I know.
Like which ones?
I don't remember, but if you tell me, I can tell you if I know or not. I don't remember much, but if you write it down, I can tell if I know or not, if I remember it.
See, I will tell you. There are different methods. Methods of solving. Methods of solving limits. First method you have learned, direct substitution. Simply putting the value. Direct substitution. Direct substitution basically means what? Like questions like this type. Like if it is given limit x is tending to 2 and you have here it is given x plus 4. So you directly put the value and it is always defined. So 2 plus 4, it gives you 6. This is called direct substitution. It's very close to it, so we can directly put it and it is defined. Okay, so that is called direct substitution. Then you have learned about factorization. Factorization. Let's say if a question comes like limit x tends to 2, x square minus 4 over x minus 2. See, now here you cannot directly substitute it.
So we have to first expand x square minus 4.
Yes, because we cannot, that's why the name is factorization given to it. We have to factorize it. So that is going to be x plus 2 times x minus 2. Because if you put directly 2, so it will be 0 over 0. And 0 over 0 is an indeterminate form. So whenever indeterminate form, we have to simplify it by some way or the other. We have to simplify it for that. So now this is x minus 2. So this and this got cancelled. So it is only x plus 2. The value of x is 2 and this is 2. So that becomes 4. Got it?
Yeah.
Now, next thing is you have done rationalization. Have you done? Remember that?
Yeah.
Rationalization you must have done. So what does the rationalization say? What is the condition of rationalization? We have the terms fx and gx. If any one of them or both involve root, any one of them or both of them involve root. Okay, so rationalize and go back to direct substitution. DS, direct substitution. So whenever you get an under root thing like, then what you have to do, you just rationalize it and then go to the direct substitution. Got it?
Yeah.
Okay.
Yeah.
Understand? Is it clear till here?
Yeah,
Fine.
it's clear.
Now, next topic is
Can you give me an example of rationalizing?
rationalizing. Yes, I can give you rationalizing. Okay, I can give you. Let's say if it is given like limit x tends to 2 and this is here under root of x minus 2 and let it be x here. Okay, now what you can see here, it is x minus 2.
So we can do into root of x plus 2 by
We
x
can
plus
do
2.
into x of root and we can do under root of x plus 2 on the top. Not like this way, so it will be like this. X root x here, root x minus root 2. Okay, fine. Yeah, this will go. Root x minus root 2. So if I put here x as 2, so that will be 0. Okay, so now we can rationalize it like root x plus root 2 and then root x plus root 2. So now it's fine then.
But in the numerator, it will be a root, no, again.
No, so that's
One
not
of
the
the terms
problem.
will
No,
be.
that's not a problem. See, the problem was that if I put the 2 here, so that is making it 0. That was the problem. If we are
Okay.
getting the answer in root 2, root is not a problem. That is not a problem.
Mhm.
The problem is that we are getting denominator 0 due to that root. So now this is root x
Okay.
plus root 2, and this will be x minus this.
X minus
No, it will again be a problem. It will be again a
Oh, because 2
problem.
minus 2 is 0.
0, yes, yes. So I will give you question later on down the road. It is not verifying. I will take another question. If you want a question, just give me a second. I will give you a question. See, we can take a question for rationalization. Let's say the question is like limit x tends to 0 under root of 1 plus x, and then we have plus under root of 1 minus x divide by 1 plus x. Yes.
So into 1 minus x divided by 1 minus x
Into 1 minus x
by 1 minus x.
into 1 minus x. Why you will do? Can we don't do it by directly substituting? First,
1. Oh yeah, denominator is not 0. There's no need for this.
okay. Right. So we can directly do by substituting. So always in the question, first see if you're able to do substitution or not. So that's substitution simply. So answer is 1. Okay. Now I'm giving you rationalization question. See, x tends to 0 under root of 2 plus x.
How is the answer 1?
1 plus 1, that will be 2, no?
2
2 it will be.
by 1.
Yeah, 2 by 1 is 2. Okay, now 2 plus x, and this is minus root 2 divide by x. Now, let's say this is a rationalization problem. If you put x equals to 0, if you put x is equal to 0, that will be a 0 by 0 form. Okay, if x is equal to 0, so that will be a 0 by 0 form. Got
But
it?
even if we rationalize, we'll still get denominator as 0 only.
If you rationalize it, then no. See, if you rationalize it, now see, I told you whenever I have a square root, if direct substitution doesn't work, then you should rationalize. Here you can see if you put x is equal to 0, this is a 0 by 0 form. Yes or no? If you put x is equal to 0, so that will come as root 2 minus root 2 over 0. So that is 0 by 0 form. Now, this is an indeterminate form. So we will now rationalize it. If you rationalize it, so that will be times under root of 2 plus x plus root. Under root of 2 plus x plus root. Got it? This will be a minus b and a plus b. So that will be 2 plus x minus 2. And that will be x times under root of 2 plus x plus root 2. So now minus 2 and plus 2 got cancelled. So, and then x and this x got cancelled. So it is 1 over root 2 plus root 2 is 2. Done. This is the answer. Finish. Got it? The rationalization. Understand?
Yeah.
No. Next, we have trigonometric limits, the 4th point.
Can we, we can't solve this question by factorization?
So how will you solve it by factorization? Can you tell me? How will you factorize the root thing? It will not work out. If root is there, I told you, whenever you have a root, rationalize it. If direct substitution doesn't work, in that case, you can rationalize it. But the thing is that first of all, you see the direct substitution. Just to trick you, I gave you the first question. So there was no need to rationalize it. So just you have to substitute it and then you can get the answer for that. But in the second question, you are getting 0 by 0 form and there is no other way. We cannot simplify it. So that's why we are rationalizing it.
Okay.
And then direct substitution. Now, the 4th topic is trigonometric functions. Trigonometric limits. The trigonometric limits are this one. First one is limit x tends to 0 Sin x over x equals to 1.
Oh
Or,
yeah, I know.
yeah, this you must remember.
Yeah.
Limit x tends to
Cos
0.
x by x is also equal to 1.
Yeah, sine inverse x over x equals to 1. If the inverse thing is also there, then also it is 1. The second thing is limit x tends to 0, tan x over x. Tan x over x is 1. This is the third point. And we have the fourth point, limit x tends to 0, tan inverse x over x equals to 1. Okay. And fifth point is limit x tends to 0. If it is a cos x, so that is directly 1. And one thing to be noted, like in the first one, in the third one, and in the first and third, x is in radians. X is in radians. This is mostly I have told you, like in 11th and 12th, they are dealing about the radians only. Got it? Trigonometric limits. Understand that? So third, first, second, third, fourth.
One of the trigonometric limits, I remember it's like x by sine x or something, no? That's equal to what?
So it is the same thing, 1.
That's also equal to
Yeah,
1.
that also equals to 1. X over sine x is also 1. So you will ask why it is 1? Because if you divide the numerator and denominator by sine x, so it will give you again 1. That is also. Now, next one is exponential and logarithmic limits. See, till here you have done in your grade 11. After that, now the JEE main things is done.
Exponential also we did in 11th.
11th you did? Okay, fine. See, I will tell you, but just to remind you. Exponential and logarithmic limits. Exponential logarithmic limits. First one is limit x tends to 0. X tends to 0. A raised to the power x minus 1 over x. So that will give you log having a base e and a. And that is also written as ln.
Okay.
Now, the second one you must have read, limit x tends to 0. Now, e raised to the power x. In place of a, we have a particular constant. E raised to the power x minus 1 over x. That will give you like log base e and e. So that will result to 1. Now, the third one. In the case of third one, the limit x tends to 0, log of 1 plus x over x equals to 1. Okay, now the fourth one. In case of the fourth one, we can write limit x tends to a, x raised to the power n minus this you have to read x minus the mostly used limit. N
a raised to n minus 1. Yeah.
Yes. Okay.
Yeah.
Next one. Next you haven't learned. Right? Okay. See, if it is like 1 raised to the power infinity form, 1 raised to the power infinity form. Okay. 1 raised to the power infinity form. So that basically means if it is given like, so if it is a 1 raised to the power infinity form, so what you will do, let's say if it is written like a function fx, and this is on the top, it is gx, 2 variables, a function fx, and then we have a gx, and then it is given limit x tends to a. And the problem is like this is tending to 1 and this is tending to infinity. Got it? Okay. This
Yes.
term is tending to 1. So this will be 1 raised to the power infinity. Now, so the formula becomes, see here on the screen how to write it. See. E raised to the power limit x tends to a. X tends to a, whatever be the limit given. Then the power comes down and then we subtract 1 from the base.
This is in the exponent of e.
Exponent of e. Exponent of e. See, this thing can even be memorized as by a concept called tree monkey concept. Tree monkey concept, you can, or you can say trick, not a concept, it is a trick, you can say. See how to keep in mind this thing. Tree monkey concept, what it say? Let's say we have a tree here, and on that top, a monkey is here. Okay? See here, the same thing, like it is the tree like 1 and the monkey is like this infinity. Okay? So what we do? We write it like, again, E limit x tends to e. Now, this monkey, see here on the screen, this monkey is brought down. This monkey is brought down by, see on the screen, by cutting the tree. By cutting the tree. Got it? This monkey on the top is brought down by cutting the tree. So 3 minus 1. So this is the concept you can keep in mind. This is.
And e can be anything.
No, e is a number. It's a fixed quantity. E is a fixed quantity.
Okay.
E cannot.
Only f of x and g of x will be given to us.
Yes,
or we have to
f of x or g of x will be given to you. Okay. Got it? Understand this one?
1 second.
Because in G, this type of concept, this type of question comes.
This is only for 1 raised to infinity.
Yeah, only
not anything else raised to infinity.
Only 1 raised to the infinity. If the base is tending to 1, and the power is tending to infinity. This is for 1 raised to the infinity form. Okay.
Okay.
Now, next one. Next one, 6th point is, if let's say we have a function limit. Now limit x tending to infinity, those which have limit x tending to infinity, in which the polynomial numerator is fx and denominator is gx. So the polynomial, this is given the format like a0 plus a1x plus a2x squared, so on. And the last term is amx raised to the power n. And similarly, we have b0 plus b1x plus b2x squared, so on, bmx raised to the power. Now here we have 3 conditions. One is if the highest powers are equal, then the answer is am divided by b. Next thing is, if m is less than n, so answer is 0. If m is greater than n, so answer is infinity. In that case, am times bm will be greater than 0. And the last condition we have, if m is greater than n, it is minus infinity when am times bm is less than 0. Basically, we are discussing the powers. You can see that we have, whenever we have a 2 polynomial function, one in the numerator, one in the denominator, so we have to see for the powers, the highest power. If the powers are equal, so just take the coefficients of them. If the power of numerator is less, so answer is 0. If the power of numerator is greater, so answer is infinity. If am times bm is greater than 0. And if it is minus infinity for m greater than n. Okay, got it? So,
Yeah. Should I join the meeting again? I think it's going to end.
Yeah, you can join the meeting. Next, we have a L'Hopital rules, L'Hopital rule that is called, that you haven't done before, I think. L. It is read as L'Hopital rule. It's hospital written like Hospital. And in short, it is called LH rule. What does this rule say for doing? This rule is valid for two forms. If we have a function limit x tends to, and this is fx divided by gx. Fx divided by gx. And what you find it is in the form of 0 by 0 or infinity by infinity. Infinity by infinity. So we will write. And you have to keep in mind, like both fx and gx are continuous and differentiable at x is equal. Then what we do to find the limit, we write limit x tends to a fx over gx equals to limit x tends to a f dash x over g dash. We differentiate it and then put the value. Okay. Now the question arises, how many times you have to differentiate? How many times? Only 1 time, 2 times, 3 times. Okay. It depends on, let us suppose you differentiated 1 time and then you put the value of it. And again, you are getting 0 by 0 or infinity by infinity form. So again, you will differentiate.
You have to keep on going until you get the denominator as non-zero.
Until you get a finite answer. Until you get a finite answer, you have to keep on. So you will write it. We can continue the process of differentiating till we get a finite answer. Finite answer. Understand?
Yeah.
Got it? Any problem?
Yeah. No.
Understand? Is it okay now? Yeah, 7 point. Next point is like 8. So now 8th one, have you done the squeeze theorem or the sandwich theorem? No.
I don't think so.
Now I will move to the squeeze theorem or the sandwich theorem. Squeeze or sandwich theorem. So what does it basically say? This basically says, let if a function gx and a function fx, hx, hx. So this basically means that if the function this gx and hx, gx and hx is defined for some particular value, then hx will also be defined for that particular value, because hx is sandwiched between the two functions. Let's say if this is a function and then this is a function, and let's say this is a function. So this is the sandwiched function between them. So whatever be the value, this will get L. And if this get L limit, then this is also tending to L.
Okay.
So if a function is sandwiched between the two functions, and those two functions are like whatever the property they have, the middle one also will have the same property. That means limit x tends to a gx equals to limit x tends to a hx, and they are both tending to limit. Therefore, that means limit x tends to a, fx will also tend to a. This is the concept.
Okay.
Got it?
Yeah.
So if the two outside functions are having the limit L, then the function which is sandwiched between the two functions which also have the same limit L. Got it? That is the squeeze theorem of the sandwich. We'll be using in some JEE questions too. Now, next we have expansions. Next is expansions. Whenever we are learning about the expansion, so that basically means which expansion? Like e raised to the power. So that will be like 1 plus x plus x squared by factorial 2 plus x cubed by factorial 3 and so on. Understand? Now.
Yeah.
Next we have log of 1 plus x expansion. If it is like log of 1 plus x. 1 plus x, not 2 plus x, 1 plus x. If it is 1 and then x. So the expansion is x minus x squared by 2 plus x cubed by 3 minus x 4 by 3. Then next one, the sin x. Sin x expansion will be x minus x cubed by 3 factorial plus x 5 by 5 factorial till 3. Till all go to infinity. All are going to infinity. Only 3 to
So sin x will be odd number only.
yeah, odd numbers only, correct. And the cos will be even number. 1 minus x squared by factorial 2 plus x4 by factorial 2. So on. Then we have the tan x. Tan x will be x plus x cubed by factorial 3 plus 2 by 15 x raised to the power 5 and so the expansion of e raised to the power x log of 1 plus x.
Why 2 by 15?
No, we don't have to go for the proofs. Just we have to,
Oh.
no proofs are required.
So after 2 by 15 x raised to 5, what will be the next?
Yeah, it is not required. Just 3 terms are sufficient. Just it meant 3 terms. So we'll do the limits is now done. After limit, you have done the continuity. So we'll do that continuity. So the topic is now continuity of a point. continuity at a point. See, first of all, try to understand it graphically. Let's say this is a point A, okay? This is a point A, and we are approaching to this point from left-hand side like this. And we're approaching to this point by right-hand side like this. Okay? See here on the screen. We're approaching to this point A from left-hand side like this one, from right-hand side like this one. But you can see a small gap is here. So when they really meet or this gap is filled, so then the function becomes continuous. So continuous means no break, no breaks. Okay, so you will write it like a function is said to be continuous. A function is said to be continuous at x equals to a, and a belongs to domain of fx, domain of fx. So if they are continuous, therefore it will be like limit x tends to a minus fx, that is equals to limit tends to x tends to a plus fx, both will be equal, and that is equals to f. All the values will be equal, tending to a, tending to n, that point. All the values are equal. And simply we can say now limit x tends to a, fx equals to f. Done. This is the function.
Okay.
Okay. Noted?
Yeah. So for this, we have to check no x if it's tending to a minus or a plus.
Yes, we have to check a minus or a plus. A minus means left hand side, a plus means right hand side. Okay, both are equal, and that is equal to at the point A also. All these values are equal, then we can say the function is continuous. If LHL equals to RHL equals to that point, if all the three are equal, then we say the function is continuous. If all the three conditions verify, then we say that the function is continuous. This all three situations to be verified. Then only we can say it is continuous. Got it? Next we have continuity at an interval. Continuity at an interval. Continuity at interval basically means on open bracket AB. So that means
A and B are not included.
yes, if f is continuous at all points belongs to A comma B. Next, on closed bracket end means if f is continuous on A comma B and at A and B also. Okay, understand till here?
Yeah.
Now in the coming session, discussing about the reasons of discontinuity. This is about the continuity of a function. We have done about the continuity of function. And now how the function will be discontinuous? What are the reason of function to be discontinuous?
If LHR is not equal to RHR,
Yeah,
right?
that are the few conditions, and we'll see how it works.